All right, let's get right into it. We pour so much time and energy into crafting these amazing machine learning models, right? But what happens after we launch them into the wild? Well, today we're going to talk about building the ultimate immune system for your AI. We're going to turn those fragile models into truly resilient, self-healing systems that don't just break, they learn and adapt. Now, this statistic right here, this should be a massive wake-up call for any MLOps team. Seriously, we stress out over code bugs and syntax errors, but this tells us the real enemy is something you can't even see. It's this slow, quiet degradation of your model's performance as the world just changes around it. And that, right there, is the biggest challenge we have to solve in production.
That really is the million-dollar question, isn't it? I mean, if your model's performance is slowly sinking, but the code is perfectly fine and the server is humming along, how in the world do you know something's wrong before your business metrics take a huge nosedive? The answer, in one word, is observability.
Okay, so first, let's identify the culprits. Let's unmask these silent killers. We're not talking about sudden, dramatic crashes. Nope. These are subtle shifts, these little changes that quietly eat away at your model's accuracy and its reliability over time. Because, let's face it, the world isn't static, and your data sure isn't either.
And they usually come in three main flavors. First, you've got data drift. This is when your input data just doesn't look like your training data anymore. Maybe your user base gets younger, for example. Then there's concept drift, which is even trickier. This is when the very meaning of what you're trying to predict changes. Think about how customer churn might change during a recession. And finally, you have operational drift, where your own infrastructure, things like latency spikes, becomes the problem.
So, how do we actually fight back against these silent killers? Well, we stop reacting and we start getting proactive. I want you to think of a proper monitoring setup as model health insurance. It's this system that is constantly watching over your AI 24/7, ready to sound the alarm before a tiny little issue snowballs into a full-blown catastrophe.
And your insurance policy, it's built on these four pillars. You gotta check everything. First, data integrity. Is the data coming in clean or is it a mess? Second, drift. Is this new data starting to look weird compared to our baseline? Third, performance. Is the model's accuracy actually dropping? And fourth, ops health. Is the underlying system itself even healthy? You cover these four, and you've got all your bases covered. Now, of course, you don't have to build all of this from scratch. That would be crazy. A really robust monitoring system is built on a stack of powerful and often open source tools that all work together in harmony. So let's take a look at the core components of that stack.
So here it is, your foundational trio. Think of MLflow as your model's detailed library card catalog. It tracks every single version and experiment. Prometheus is like the tireless librarian, constantly recording every single performance metric 24/7. And Grafana, that's the big, beautiful dashboard in the lobby showing you all those real-time stats in a way you can actually understand. But to really catch that silent drift, you need a specialist. And that's where a tool like Evidently AI comes into the picture. It is the canary in the coal mine. It's designed specifically to run all these complex statistical tests and spot data issues that Prometheus by itself might totally miss. And here's the best part. It can often detect problems without even needing fresh labels, which, trust me, is an absolute game changer. All right, so we know the what and we know the why. Now it's time to get practical. Let's actually talk about how to build our MLOps watchtower. Here's the playbook.
It really just boils down to these four key steps. First, you instrument your code so it can actually report on its own health. Second, you define the rules. What does bad actually look like? At what point do we care? Third, you set up notifications so the right person gets a ping on Slack or PagerDuty. And finally, number 4, you automate. This is where the magic of self-healing really starts to happen.
And this slide right here proves this isn't just some high-level theory. This is real, concrete code. On the left, you can see that little Python hook that exposes a model's health metrics. And on the right, that's the actual rule that tells the system, hey, if the data drift is high and the performance has dropped, you need to sound the alarm. This is literally where our watchtower gets its eyes and its ears. Getting an alert that something's wrong is good, but having the system fix the problem for you, that's great. That is the ultimate goal here, to create a closed-loop system where detecting a problem automatically triggers an action to fix it. And hey, this isn't a one-size-fits-all response. We use what's called a remediation ladder. For a really minor issue, maybe you just pause traffic to that model for a bit. For a critical drift alert, though, the system can automatically trigger a rollback to the last known good model that you have stored in MLflow. And, of course, the most severe or weirdest issues can trigger a full retraining pipeline or get escalated for a human to review. So, what's the actual payoff for all this work? I mean, what does this get you? Let's look at the real-world impact and some of the hard-won lessons from teams who have actually gone out and built these incredible self-healing systems. The impact is, well, it's staggering. A 5-fold reduction in mean time to resolution. Just let that sink in for a second. We're talking about problems that used to paralyze a team for hours, maybe even days, that are now being fixed in minutes, often before a human even sees the alert. That's a huge deal.
And look, this isn't just about saving developers' time, it's about saving money. A lot of money. One team saved $500,000 in a single quarter. How? By automatically catching a silent drift issue that was quietly robbing them of 18% of their fraud detection model's effectiveness. That is a massive, undeniable return on investment.
So, how do you get these kinds of results without just drowning your team in false alarms? Well, you follow the architect's playbook. You have to tune your alerts ruthlessly. Start loose, then tighten the thresholds over time. Never ever rely on just a single metric. A multi-signal alert is way more reliable. And always, always connect your technical alerts back to the actual business impact.
If you take just one thing away from all of this, let it be this quote: "Your model is never done. The second it's deployed, it starts to age." Adopting this day one mindset means you treat monitoring not as some boring task you do at the end, but as a continuous, absolutely core part of the entire MLOps lifecycle. So I'll leave you with this one question to think about for your own systems. Because without robust, automated monitoring, a production model isn't just an asset, it's a liability. It's a ticking time bomb just waiting to silently fail. The tools and the playbook are out there. The only question left is, are you ready to start building for resilience?